On this episode of the Dairyland Initiative podcast, we're going to be talking about adult cow ventilation. Hi, I'm Courtney Hallbach.
And I'm Nigel Cook,
And this is the Dairyland Initiative podcast.
where we get to discuss issues related to the housing and management of dairy cattle.
Let's dive in.
Well, today, Courtney, we're returning to the topic of ventilation, only this time we're going to talk about adult cows.
Oh, come on. You didn't like talking about calf barn ventilation in the previous episode?
I did, actually. It was kind of fun.
I could see you were enjoying yourself. But we'll get on to a topic that is more in your wheelhouse with adult cow ventilation today.
Let's do it. This has been a focus of ours for a number of years now, trying to really get our heads around all the different approaches that we're using on the adult cow side.
Yeah, because when I came in to the Dairyland Initiative, you were really strong on calf barn ventilation, a lot of focus, winter time, and improving air quality in calf barns. But I would say, I think it was like 2016, we were still really up in the air with what
Well, this
was good adult
interest
cow
was
ventilation.
just triggered by questions. Email, phone in, just people asking questions about ventilation in adult cow barns. And we were doing in the industry lots of different things with no sort of clear plan.
Yeah, there was no real research. So
Yeah.
your focus, with the help of Dr. Mario Mendaka, was really trying to focus on what are the adult cow ventilation systems that are available to producers, pros and cons of those systems, coming up with some criteria, and then figuring out how we can assess existing ventilation systems.
That's right. And on the adult cow side, we're still worried about pneumonia and winter ventilation rates, but the major focus is the summer.
Yeah.
It's summer heat stress.
And our cows today are producing a lot of heat compared to those.
Yeah, 120 pound of milk per cow producing twice as much heat as a cow producing 40 pounds of milk per day.
Yeah, so the systems that were designed 20 some years ago just aren't.
Yeah, we were
able
getting
to-
calls from farms. Hey, my cows are really struggling this summer. They didn't used to. The barn hasn't changed. Well, the cows changed, and those cows produce so much more heat than piffling little resting human beings. 9 times more heat.
Oh, yeah, I don't know. I think it might be a little different for you because I feel a lot of hot air coming from your side of the room.
Ouch. Ouch. I gave you the setup there,
You did.
Courtney. I gave you the setup. She took it. Yeah, and that's a key point here, that if you go to a farm and the people say, yeah, we turn the fans on when we're hot, wrong, because the cows are heat stressed well before humans are having trouble with heat.
And I think that was a very shocking thing to me because, as farmers, you really are thinking about well-being of cows. And so you're thinking, okay, I'm feeling heat stress. The cows are feeling heat stress, but their biological needs are much different than ours.
Yeah, so they're getting impacted by heat at around 65, 70 degrees Fahrenheit, 18, 20 degrees centigrade. What we call a THI, it's a function of temperature and humidity, a THI of 68. And that number's changed over the years.
Yeah.
We used to say 72, then it was 70, now it's 68. It tends to drop about every 5 to 10 years. But cows are experiencing distinct physiological challenges during periods of heat during the summer. Decreased intake, increased respiratory rate, changes in rumen function, decreased rumination rate. All of that leads to reduced milk production, but other impacts, leaky gut syndrome, impacts on immune function are leading to susceptibility to diseases like mastitis. And there are just some broad negative impacts of these physiological changes.
Yeah. And so I have been hearing things that are easily observable. So increase in respiration rate and things. But obviously there are some things that somebody walking through a barn might not see in terms of behavior.
Yeah, absolutely. And alongside those physiological changes, there are distinct behavioral changes. And the key thing here is as the temperature increases, lying time decreases.
And we know how much you've focused on
And we're pretty
optimizing
passionate about
rest.
lying time here. So, somebody tells me cows lose about 3 hours of rest a day, I'm concerned.
Yeah.
Because what that leads to ultimately, not at the time of heat stress, but usually around 2 months later in the fall, it leads to lameness.
Yeah, you see a big spike in lameness. September, November.
October time. Yep. So the trimmers go from prevention to treatment at that point, and then that problem stays with us all winter long.
And then it happens again if things aren't changed.
So how do we keep cows resting? How do we create a ventilated environment to help control this heat stress? Because it is impacting cash flow on the farm. The reduction in milk yield and these health effects have a negative impact on the cow. This is actually our little 50-cow dairy that we used to have on campus. Not a particularly well-designed barn for controlling heat stress. And so, we went from about 80 pounds of milk to about 60 pounds of milk. And it's usually that third day of really hot temperatures. Cows kind of hang on for day 1, day 2, and on the third day they just kind of give up.
Yeah.
And you get these very dramatic drops in production. And then the type of heat stress we have in the upper Midwest, it kind of comes and goes. Cows recover over time. And so one of the key points here is that if you're on monthly milk tests, these two marks are 1 month apart, you could actually completely miss this dramatic drop in milk production.
Yeah, so it's hard to tell.
This comes back to a lot of our evaluation of the losses from heat stress are based on monthly milk production data, and you've got to believe that's an underestimate of the true impact.
Definitely.
Some really exciting research being done, University of Florida, but also with our CALS group here on campus looking at heat stress in gestation. We've been very much focused on heat stress in the lactating cow, but the dry cow is also negatively impacted.
Yes, and her offspring.
So the calf that is born during a period of heat stress is negatively impacted.
And it looks like this gets carried over through multiple generations.
Yeah, amazing. That animal, when it enters the herd and has a calf, that calf may be negatively impacted.
So we are, starting here early on, we were focused a lot on providing heat abatement to our lactating cow groups, and now we can't forget about the dry cow groups as well.
Yeah, so what we're talking about today isn't just for milking cows, it's for dry cows as well. And then you really set us up well last time, Courtney, talking about the calf microenvironment. Well, we think cows have microenvironments too.
I'll be honest, I kind of stole the microenvironment idea from you.
I think it was the other way around originally, actually. This is important to us because you have to think about not only moving air through the barn, but also the pen that the cow is living in and the lying space that the cow is occupying. Because when she's lying down, her body temperature is increasing. Remember this, cows warm when they lie down and they cool when they stand.
Just because they have so much more body surface to dissipate heat when they're standing. And it's
that helps.
Not the same rate of cooling off as increasing when they're lying down.
Yep, lying is the problem. So if we're going to keep cows lying in this stall, we have to do some things to try to reduce the rate of increase of body temperature. And so we've worked on that these last few years, and that's been a sort of major focus of research.
Yeah.
So when you look at the current, I'd say upper Midwest North American dairy industry, there's lots of different approaches to adult cow barn ventilation.
Yeah, and we've tried to narrow it down to about 6 to make the decision
well, we're trying
easier.
to keep the podcast at around 30, 40 minutes.
That too.
Yeah. So as you talked about before, natural ventilation is still very common. So if you look at the industry as a whole, housed cows, probably 85% of barns are still naturally ventilated. But if you look at new barns, it's probably 85% are mechanically ventilated, and so different options are available. These 5 options are all mechanical ventilation options, so positive pressure hybrids pushing air into the barn, and we already talked about using tubes to do that in calf barns. Tunnel ventilation systems with fans over the stalls that operate all year round, or barns that have a tunnel option for the summer and a natural ventilation option for the winter, what we call a tunnel hybrid. And then cross-ventilated barns, some with baffles, some with fans, different systems. So, 6 main approaches, which is really darn confusing when you're looking at our industry right now.
Yeah. And I'd say, the switch to mechanical has been driven by our longer, warmer summers.
Absolutely.
Our situation here in North America is relatively cheap electricity compared to other parts of the world. So we are now understanding the economic effects of heat stress, and we can justify putting more fans onto our facilities to help mitigate.
All of these options can be designed well and implemented on a farm successfully. And in North America, as you say, because of the cost of electricity, they're mostly pretty viable. Mm-hmm. That's not true in all countries.
Nope.
In countries that have less heat stress, in countries where electricity is greater cost, then some of these decisions become really marginal, and we'll try to revisit that towards the end of this podcast. Mm-hmm. So we've talked about natural ventilation before. We have an open ridge, we have open eaves, and we have adequate interior roof slope. Typically, builders will talk about 3 in 12, so a 3-foot rise for every 12 foot of building width for a typical naturally ventilated barn. Mm-hmm. And then, that helps drive with the animals inside the barn, creating thermal buoyancy, drives the hot air out through the roof.
Much easier to be done in an adult calf facility versus a calf barn.
Yep. That runs year round, and then in the summer we get the extra ventilation we need from the wind.
But it's important to be sure that these barns are free from any wind shadows. So we like to see a spacing of about 100 feet between buildings, 30 meters for our metric listeners, and then wanting to orient the barn east to west.
Absolutely. We talked about that last time, is orienting the barn east to west, and that's for our situation. That's not all situations, but based on wind direction, we see that. So we still, go into a lot of naturally ventilated barns, both here and in Europe, and I think that's going to stay around. We're going to still see naturally ventilated facilities. We're going to check that the ridge opening is the right size. We're going to check that the curtains operate the way they should. We're going to check that roof slope is appropriate. But the biggest thing I think we've seen in naturally ventilated barns this last decade has been this focus on creating air movement within the barn.
Over the stalls.
Over the stalls. Remember, cows are warming when they're lying down, and so we've been focused on putting the fans over the stall area. So in this barn, you see the fans in that location. They're not over the feed bunk. We do want some air movement in the feed alley.
Again, they're spending 12 hours a day resting versus maybe 3?
4.5 eating.
Yeah.
So the emphasis, in these barns is get the airspeed where the cows need it, lying down in the stall.
Mm-hmm. And naturally ventilated barns tend to be narrower, so we see it with 4 to 6 row facilities, and then as we start adding more rows, the barns become wider, and so that's going to tip us towards a mechanical system.
That's when it gets more challenging, absolutely. So this is some of our data from a few summers ago when we were applying different fan speed treatments over the cows, showing that when we turn those fans on, even at low versus high speed, we preserved line time. So we get line times being maintained or even increasing as temperature rises, whereas in the controls, we saw a loss in line time as it got warmer.
And that control system was just a naturally ventilated barn, so there was still air movement coming in.
We just turned the fans
with the prevailing winds. And then that low-speed treatment was air speeds of at least 200 feet per minute in the resting space, with the high-speed treatment being over 400 feet per minute.
That's what we call the MCAS, Courtney.
That's not what Boeing has, right?
Yeah, unfortunately, it is the same acronym as that software that crashes Boeing jets. But
Yeah.
I'm holding on to it. I think people will forget that eventually, whereas they'll remember this.
MCAS for minimum cooling airspeed.
Minimum cooling airspeed.
And what
That's
is
what
that?
we're talking about.
What should we be looking for?
That 200 to 400 feet per minute, 2.25 miles an hour to 5 miles an hour, or if you're in the metric system, 1 to 2 meters per second. They got it made. It's easy numbers to remember.
Way easier to remember.
Importantly, we're measuring that at resting height. So that's 1.5 feet above the stall surface, or half a meter. So it's what the cows are experiencing. It's not the average of the whole cross-sectional area of the barn.
Or the pen.
Or the pen, yeah.
It's the stall.
So minimum cooling airspeed. Remember, you heard it here first, folks.
And, why are we talking in feet per minute versus mile per hour? Because that's much more common here in the U.S.
It is. I think it's just mainly preference, but you can be a little bit more accurate with feet per minute. So that really led us to examine how air leaves a fan.
Yeah.
And you can use fog to do that, Courtney.
I know. We like fogging calf
We
barns.
like
We
fogging
also
barns.
like fogging adult cow facilities.
So air leaves a fan in a cone. Yeah. So you can kind of see that here. And immediately below the fan, for about 10 to 20 feet, there's an area
nothing.
where the animals aren't experiencing any benefit from
There's
that
no
fan.
fog.
Yeah, there's no fog. So what we have to do is try to aim these fans below the next fan so that cone overlaps.
And you're covering all of the resting
We want to
area.
bathe cows in fast-moving air.
That sounds great.
It sounds pretty nice, actually. And actually, when you're lying in a stall, it is pretty
It
nice.
is nice.
Yeah, to get that degree of air movement, that's going to keep our cows lying down and comfortable in the summer.
So it's really, how the spacing between fans, the angle of fans, how high they are from the stall base.
Spacing and angle, there's a lot to it, and there's a lot of variation between fans. So the actual spacing and recommendations is really fan dependent.
Yeah.
And that means you have to go and measure what those fans are doing in terms of the throw distance, how far that airspeed is reaching from the fan.
I love that we have another excuse to get into the stalls.
Yep, absolutely. We're turning these fans on typically around 68 degrees Fahrenheit, 20 degrees centigrade. Some farms are pushing that probably down to 65 in certain circumstances, but that's kind of the trigger temperature, the threshold we turn these fans on.
Yep. So it's important to have these on an automated thermostat, and ones that do take into account humidity as well.
Correctly. That's great if you can get the humidity piece in there as well. So we can go to barns with our little airspeed measuring devices, put them on tripods, and do airspeed maps. And on this airspeed map, black numbers are good. They're above 200 feet per minute. Red numbers are bad. You can see on this barn, 55-inch fans spaced 36 feet apart. You might look at it and go, oh, they may be a little too far apart. But actually, when you do the measurement, it's looking pretty good. The only space we have that's a problem is just in that
Directly
triangle
under the fan.
directly under the fan.
Without a fan before it. So what can you do?
Hard to resolve that. To resolve that. But otherwise, the spacing, the angle, and the positioning in this barn looks really good.
Looks good.
And we've been to very similar farms like this, and all those numbers have been red because the angle's wrong.
Yep.
Yeah, so it really is spacing and angle. So you mentioned wanting to get the wind into barns, Courtney. So
Yeah, and this picture, I don't know how you found this or who decided
Chris
to build
Isley
this.
took this. He likes to climb up those blue staves and take pictures of farms. So I think there's probably 20 feet between these barns. This is the issue of farmsteads. We're always trying to maximize the number of animals we can fit in a space, and in this situation, we're compromising natural ventilation.
Yeah, and there's also a concern on larger herds. Having cows walk really far distances. So when we say naturally ventilated barns need 100 feet.
You're adding another 100 feet each direction to the distance that the cow has to walk to the milking center.
So
that's
it's just
bad.
not feasible.
Yeah, Yeah. And then the other issue that we're experiencing, and really explaining why farmers are looking at mechanical systems more than natural ventilation systems currently to provide that higher air exchange, is that sometimes the wind doesn't blow.
Nope.
You showed these windrows maps in our last episode, wind generally coming from the southwest in the summer. But these graphs also show when the wind isn't blowing, and it's about 20% of the time in Madison in July.
Yeah, that's not good. There's a lot of hot days in July here.
And it's always hot for Wannerfest, folks. So I can absolutely tell you that sometimes the wind doesn't blow.
And you need a fan in those tents, don't you?
You need a fan in those beer tents. So I think that really explains why, when you can afford to do so, when electricity costs allow it, that we are pursuing different mechanical ventilation options, both positive, forcing air into the barn, and negative pressure systems, drawing air with negative pressure through designed inlets, using fans to exhaust air out of the facility.
So instead of an open curtain with wind coming in, we're now relying on fans to mechanically.
We've still got a curtain, but we've got a designed inlet designed to create incoming airspeed at around 500 to 800 feet per minute to allow that air to mix with the stale air in the barn, and then using negative pressure to help draw that air through.
And out of the mechanically ventilated barns that we're seeing, most of them are negative pressure.
Funnily enough, yeah. On the adult side, the predominant focus has been negative pressure. We're starting to see some positive pressure options, and we can sort of show a few of those. But when you're designing them, actually, in terms of the numbers, it doesn't matter, positive or negative. You still design around air changes an hour.
Yep.
Exact same recommendations as calves for the winter, 4 to 8 air changes an hour, up to 40 to 60 typically during the summer. And just based on the designs of these facilities, tends to be around 40 or 50 for a tunnel, 50 to 60 for a cross vent, and we can kind of look at those examples. But also, you know, as with calves, realizing that the air per animal is important. Mm-hmm. So a threshold of around 1,500 cubic feet per minute per adult cow in the summer, or about 2,500 meters cubed per hour. Mm-hmm. That's an important threshold not to completely ignore, as we tend to sneak a few extra cows into these barns.
Yep, and cross vent systems have another added requirement to them for design, and so for a cross-sectional airspeed in cross vents with baffles over the stalls, we'd be looking at designing around 500 feet per minute, or 2.5 meters per second.
Yeah, and those systems are going to drop a solid barrier, a baffle down from the ceiling and drive air into the stalls. That's where we need the airspeed, so we're going to put it over a stall platform and get that nice fast-moving air.
So instead of a fan, you'll have either a curtained or a steel aluminum
Correct, yeah.
baffle.
Yeah. So these positive pressure systems, the tube systems probably more so in Europe, I think, because of the cost of electricity and how efficient these systems are in terms of fan usage. I call these dungeon barns.
Yeah,
Courtney.
Their barn designs are also a little bit different than ours.
Breeze
much
blocks
more
to
enclosed.
8 feet, no openings, low ceilings. Ugh.
It's a lot harder to place multiple fans on the end of a barn. So
so these tube systems can bring air in. Bringing fresh air in's never a bad thing.
Never a bad thing.
But there are designs similar here. You can see the tube systems over the feed bunk in this scenario. But then we've gone all in on this big positive pressure hybrid concept.
Mm-hmm. And this is seen in not too many farms, but it's becoming more popular, and partly because it's not something you can renovate into an existing facility unless you have a 4-row barn with head-to-head stalls.
It really does lend itself to that layout. Mm-hmm. So it's a 4-row, 2-row pen head-to-head stall layout, just based on the fact that you're putting fans instead of over the stalls. You're putting the fans on the side wall and directing air at the cows.
And because you just showed that fogging video of air not flowing directly underneath the fan. You need that space for the air jet to reach the cows in the stalls.
Yeah, correct. So that and I'll show you that the alignment of that is critical. So this is a barn that can naturally ventilate when you don't run the fans, because you've still got curtains on the side walls. You've still got an open ridge that you can open and close. This has got a curtain at the top. And it can be joined on to an existing naturally ventilated barn. Because you're forcing air into this barn, all that air will do is leak into the other barn. So there's no concerns about creating that negative pressure.
Mm-hmm.
The issue, as you've said, is all of these housings are custom built, and there's a lot of fans, and you have to direct them appropriately. And when we're fogging, sometimes we see that air jet can miss the first row of stalls if you don't get it right. And so that angle is critical again.
Yep, and you can, just fogging, you can see where airflow is going, and also using an anemometer to pick up the air.
Yep.
If you're trying to figure out when you're installing, how do I angle this fan?
But you see a very different barn aesthetic. There's no junk up here. It's nice and clean.
Very big open space.
Yeah, big open spaces. So I like it from that perspective. The negative pressure systems, as we've sort of alluded to, are usually characterized either as tunnel or cross.
Mm-hmm.
So when we say tunnel ventilation, what we're doing is drawing air down in the direction of the feed lane.
Mm-hmm. So along the length of the barn.
Along the length of the barn.
Parallel to the feed lane.
Yep. So you've got inlets at one end, fans on the other, drawing air down the length of the barn. So that's a tunnel.
And across, you're drawing air across the width of the barn.
Perpendicular to the feed lanes. Yeah. So this time we've got fans drawing air out on one side and an inlet running the entire length of the barn on the other side.
Mm-hmm.
And there are some subtle differences in how that air goes over and around the cows as they stand at the feed bunk. I would just say there's just pros and cons of each of these systems.
Yeah.
So let's look at a few of these types of system. So this would be a barn in Australia. Directions for the system, similar to your positive pressure tubes in calf barns, Courtney. Turn it on.
Yep.
It stays on all year round, and that means you don't need curtains. And I didn't realize before we got into ventilation how much farmers hate curtains.
They really hate them.
They're expensive.
They are.
They're expensive. They tear. There's maintenance involved.
There's management of having to
You have to decide when to open and close them. They're not as popular as I thought they were. And so somebody comes along and says, hey, you can build a tunnel and put some polycarb up. All you got to do is power wash it every now and again.
Not a bad
deal. That's what this is. Low-roofed tunnel, purpose-built tunnel. So you don't need that high ridge anymore. You can close it down, reduce the air volume that you have to ventilate, get the air movement closer to the cow, and cheaper polycarb sidewalls.
But you just said, the lower roof helps keep air closer to the cow, but it doesn't get it quite back down into the
Doesn't quite get
stalls.
it close enough. Yeah, people have used baffles in tunnels or lowered the ceiling. Bottom line, to get the MCAS, the air speeds that we need to keep cows lying down in the stalls, you've got to put fans back over the stalls.
To help redirect that air into
so
the
as
cow
we
microenvironment.
did in a naturally ventilated barn, we're doing in a tunnel barn.
Wow. Who would have thought?
We've come full circle, which there's an advantage there. So if you're doing remodels, Courtney, you can do this
in stages.
Yeah. Because in a tunnel, you're still going to need those fans over the stalls. So put them in first, see what impact you have from that.
And then if you need a switch from natural to tunnel,
you can do it.
Close up the curtains.
Just close it up. Yeah. This was our old friend Mario Mandaker. Challenged him to try to explore different ventilation rates and work out how much air the cows were actually getting in their microenvironment.
Yeah.
So this was a computational fluid dynamic model for a tunnel ventilation system. And at 60 air changes an hour, he basically showed us that only 13% of the total ventilation of that barn is actually where the cows live.
Well, that's not what I would have expected,
So there's a lot of air flowing through this facility,
but not where the cows are.
not where the cows are. So that's why we have to rely on these fans to create that localized airspeed that
Over
the cows
stalls.
need. Yeah. This overall ventilation up here, that's what gets rid of the heat.
Yeah, it's important. It's still important.
Absolutely gets rid of the heat, the moisture, the noxious gases, and the dust. So that gets you fantastic air exchange.
And good air quality inside the barn.
Predictable air exchange, which we don't have with natural ventilation systems. This is a favourite barn of mine close to where I live. Nice retrofit. So the existing, the old naturally ventilated barns down here, and they built this extension on, which is basically involving these designed inlets on the end and the side walls. The air's being drawn down in this direction, and you see the fans on the end of the barn, but also fans over the stalls
Over the
again.
stalls.
And yet another example, a naturally ventilated barn built probably 20 years ago now, converted with fans, exhaust fans on the end wall, and a designed inlet on the other end to create that airflow.
And it looks like they have chimneys.
They have chimneys that they can open and close. You can use the chimneys as another inlet, or you can close them up when you're using this barn as a tunnel. And that would be what we call a hybrid tunnel. So if you see barns with lots of fans on the end wall, that's tunnel ventilation. But if they also have curtains, and some of these are newly designed or just retrofits where you leave the existing curtains in place, you can switch in the winter from having a curtain ridge natural ventilation system to closing the curtains and running a tunnel ventilation system in the summer.
So, and some producers really like that flexibility.
I think it's really good for varied climates where you can benefit from that flexibility. But, and there's always a but,
Those curtains.
these barns cost more money to build because of the curtains.
Yep.
So if you're retrofitting and the curtains are already there, it makes sense. If you're not, then you really need to look at this as, is this worth it? Because if it's hot all year round, you don't need the flexibility, and therefore you don't need the cost of curtains. The cross ventilation systems lend themselves to these bigger square barns, often with usually 3 feed lanes.
Yep.
So 8 to 10 rows of stalls.
A little bit wider.
Pens that are back to back. And what you see here are baffle systems, and here we've got curtain baffles dropping down to create that airspeed where the cows are lying down in the stalls.
And the baffles are better suited for a cross-ventilated barn rather than a tunnel because they influence air movement in more stalls.
You can drop them down to 7-8 feet above the stall, and then move that air at high speed through that resting space. So that's the key. On a tunnel, the baffle would have to go across the barn, perpendicular to the stall platforms, and you wouldn't be able to drop it low enough to really influence the cow microenvironment. Exactly. So that's why we've kind of gone away from using baffles in tunnel systems. The baffles are really for these cross-ventilated barns. But in both of those systems, the new barns have lower roof pitches.
Yes.
So now we've gone from 3 in 12 for a typical naturally ventilated barn to 2 in 12 for a tunnel and half or 1 in 12 for a cross-ventilated barn. There is no natural ventilation option for these cross vents. So they're really purpose-built for mechanical ventilation year-round.
Yep.
Some farmers don't like the baffles.
No, they might not be aesthetically pleasing.
Aesthetically,
sometimes.
closes in the barn. Yep. Functionally, you have to clean them, and and they do tend to trap air, particularly in the winter. So for that reason, people look for options. I'm going to try to show you an example of what happens to that air under the baffle.
We're fogging again.
Got to get the fog machine out. Love this thing. So it really whips that air underneath the baffle at high speed. But what you also see is it kind of circles around. It doesn't go shooting off to the next area and the next baffle. It kind of spins around, so that airflow becomes trapped. And if that warm air condenses against the ceiling, then you can have moisture buildup and dripping in these barns.
Yeah, so it's really a problem in the winter because we are only running the exhaust fans at 4 to 8 air changes
Lower
an
air
hour.
exchange, yeah.
But then in the summer, when we are closer to that 60 air changes per hour, it still is circulating between the baffles, but it's not staying there as
The
long.
air doesn't spend as long in the barn. The retention time is lower. But if you get everything designed right, you get the baffles in the right place, make sure that the barn isn't too wide. So this is a 10-row example of a cross-ventilated facility. We've airspeed mapped these barns, and in this particular scenario, there's no red.
No.
That means there's not a single stall under 200 feet per minute.
So it is possible to
It is
design
possible.
a perfect barn.
It is possible. This would be pretty close to perfect. So as we said, some people don't like those baffles because of those potential issues, a lot of which is resolved by using curtain baffles instead of solid baffles. But again, still aesthetically, some people don't like that. So others will build cross-ventilated barns, have the air direction in perpendicular to the feed lanes, but they'll use fans just as we used fans in tunnels, but this time perpendicular to the feed lane.
But I can imagine that's going to increase the operating costs.
It sure does. You're adding cost to the fans, installation, purchase, wiring, and the electricity costs.
And then you got to maintain more fans.
Yep. So a difference there. You've got to pay for the baffle up front, but then you don't have to pay for the electricity that airspeed that baffle creates. Whereas in this scenario, you have to pay for the setup and the running costs. So that has been a focus of ours is, are these systems worth it?
Yeah.
And so Mario really put the math together to allow us to have a spreadsheet that we use in our design workshops to address running costs. So this actually calculates how much it would cost to run these systems based on a typical meteorological year using weather data. So you can put in your zip code and you'll get the days above temperature of 68. So you'll know when the fans are being turned on and off. And this gives us an estimate of running costs.
Yeah. And then it also allows us to compare to the bare minimum costs of heat stress.
Yeah. So Norm St. Pierre did a study way back. I think it's 20 years old now.
Yeah, 20.
That used DHI data, so that sort of monthly test data to give us an estimate of heat stress losses. And you might say, well, it's flawed data and it's old data, but at least it's data.
It's what we've got.
Many countries don't have anything, so we're really just guessing. So we use that as a baseline. So when you're looking at running costs, if those running costs are less than the estimated losses of heat stress from those old 20-year-old equations, we think we're in good shape.
Yeah, then it's worth
putting these systems in. So to give an example of that, one of the fun activities we do in our workshops is get our participants to design an 800 cow barn, just to keep things manageable, 200 cow pens, and then apply different ventilation systems.
Yeah, so those 6 ventilation systems
the 6
we just
famous
talked about.
ventilation systems, natural ventilation, positive, 2 tunnels and 2 crosses.
Yep.
And we get them to, calculate the cost of running and installing these systems. So in Madison, Wisconsin, the cost of heat stress is at least $123 per cow per year.
Okay.
It could be 250.
Yeah, so
it's probably not less than that. Okay, so that's our kind of ballpark figure. And we're using at the moment 15 cents a kilowatt, Courtney.
Yeah, that's gone up.
It's gone up. It used to be 10.
Yeah.
It's pretty regional, though. You can do deals. We've heard people, at 5 cents a kilowatt. We've heard people more than that. But that's kind of our US average right now. And all of our European listeners are going, what? Because,
it's cheap.
They could be paying 30 or 40 cents a kilowatt. So cost of electricity varies throughout the world. So bear that in mind.
So, and then when we are designing this 800 cow barn, you're looking at how many fans there are per system.
Yep, how many fans, how many total fans. So a naturally ventilated barn is the cheapest system to run
Yeah.
because it's got the fewest fans and you only run them in the summer.
Mm-hmm.
So for about $28-30 per cow per year, you get your natural ventilation.
And hey, the system is less than the possible marginal losses from heat stress of 123
Much less.
per cow.
Yeah, if that natural ventilation with fans over the stalls gets us a little bit of savings, we're ahead.
Yep.
Yeah. And for example, in Florida, the cost would be about double.
Mm-hmm.
So think in those terms, you could double the cost of.
They're hotter. More days in the year.
It's on all the time. So a mechanical system, pretty variable costs of running. The positive pressure comes out pretty good on the cost of running these systems because, again, it doesn't run all year round.
Mm-hmm.
It's only running during the summer when you
I'm
need
guessing
it.
There's some other costs associated with the positive
There's a lot of
pressure.
fans. When you spec these out, there's over 200 fans for this in this scenario. So that's 2 to 3 times as many fans as other mechanical ventilated systems. So a lot of wiring, copper wire's expensive, a lot of installation, a lot of boxes that you have to hand build to get the angle right for those.
So you're
fans.
paying more upfront.
It's more upfront costs, but again, the
Operating.
cost of operation may be certainly less than double, but about $46 per cow per year. The cheapest mechanical system after the positive pressure is the cross vent with the baffles.
Yeah.
Because again, once you've got those baffles installed, they're creating free, fast-moving air.
Mm-hmm.
So in Madison, Wisconsin, we can design these systems about double the running cost of a naturally ventilated system, about $64 per cow per year. So, still half of the potential losses. So
yeah, it's still reasonable.
very reasonable. And actually, the hotter it gets, the more efficient the cross baffle looks compared to natural ventilation. So again, in Florida, you could run a cross baffle cheaper than a naturally ventilated system because those inefficient circulation fans are running all the time and the exhaust fans are running all the time, but they're more efficient. So they use less electricity. The other mechanical systems, the tunnels, the cross with fans, generally higher running costs, generally around $80 per cow per year right now to run those systems. Still cost effective.
Yep.
But they run at higher installation and running costs.
So here in Madison, Wisconsin, if we were to go and build an 800 cow barn today, all of these options
We've got
are
lots
viable.
of options. They can all work. They're all economically viable. So there's preference comes into play here. But if you're kind of looking at the bottom line for performance and cost, that cross baffle looks really
looking good.
Yeah, because we can ensure fast moving air where every cow is lying down, and we have predictable air exchange, which you don't have with the naturally ventilated barn.
Mm-hmm.
If you start to look at 40 cents a kilowatt, some of these numbers start to get a little high. Now you're talking at $200 per cow per year to run some of these mechanical systems.
Okay, now it might not be as economical.
You got to really look at your potential savings from heat stress losses.
Mm-hmm.
So in certain situations, they may well still be viable. In others, we're a bit cautious.
Yeah.
We're a bit cautious. You got to really take a close look and see if this is a viable approach or not.
Yeah.
You can save some money by selecting the right fan.
Oh, I thought you were going to say by cutting coupons.
No coupons in this deal, but you can go to a manufacturer and say, hey, what are the range of fans that you have? So this is one manufacturer. We're not going to say which one because it really doesn't matter. But we're speccing the same barn at the same air changes an hour. So actually 40 air changes an hour for 1,500 cows tunnel system. And we're using different fans, a 55-inch fan, a 60-inch fan, a 72-inch fan, and calculating those operating costs.
Mm-hmm.
And it blows me away that there's a $20 per cow per year difference depending on the type of fan you use.
It really comes down to fan efficiency and looking at that CFM per watt.
Yeah, the amount of air that's moved by the fan per watt of electricity. Look at the efficiency. It's not the only thing that determines choice. Lots of other things come into play, is how well that performs under negative pressure, if you've got to exhaust air into oncoming wind, noise, lots of things come into play. But please look at the efficiency, because that is important, because it has a huge impact on the overall running costs of these facilities. As does maintenance. And this is one of my catchphrases, Courtney.
It is.
Every fan you hang is a fan you have to maintain. Yeah. So
let's put that on a bumper sticker.
It needs to be on a bumper sticker. But that is true. A lot of these systems use a lot of fans, and every time you install one, you've got to maintain it. So we go to a lot of facilities where maintenance isn't up to date. You can see the dust buildup on these louvers is pretty egregious.
This is where I go in and write "clean me" in the dust.
Yep, you can certainly do that, but you can lose at least 25%, maybe even 50% of the efficiency of these systems just from poor maintenance.
So just to put that into perspective, you got 100 fans running and you haven't maintained them, so a lot of dusty buildup, and because you haven't cleaned it, it's basically only 50 to 75 of those fans.
Yeah, and we give the fan salesman a hard time, but that's not their fault. Yeah, when they design the system to work, you can't go back and complain, oh, the system's not working, when you've overstocked the barn at 1.5 cows per stall and you've not maintained the fans or the louvers. That's not their fault. And this isn't for every farmer. Some farmers don't want to commit to this amount of maintenance. They don't have time. Yeah, it takes a lot of time to get feed in front of cows, get the milk in the tank, get all the family chores done. So horses for courses. Yeah, when you're discussing these different systems, you need to go into them eyes wide open, because there are running costs, there are maintenance costs, and time.
Yeah.
And time is something we don't have a lot of on dairy farms. So I'm going to finish at the point where we realized that there wasn't one perfect ventilation system for adult cow barns. There are these different systems.
But they all have to have certain criteria. That's
what we tried to look at, is say, okay, you're using different approaches, but what are the criteria that work? So these are the 4 main criteria that we use to define an effective ventilation system, and that is, number 1, sufficient air exchange.
So getting that 4 to 8 in the winter, up to 40 to 60 in the summer.
And that's where our naturally ventilated barns fail the most, because you don't have control over that extra air exchange you need in the summer for adult cows. The second is target airspeed in the resting microenvironment.
So that's getting that 200 to 400 feet per minute, or 1 to 2 meters per second, at 1.5 feet or 0.5 meters above the floor.
The MCAS.
The MCAS.
The minimum cooling airspeed at cow resting height. Realizing that, it'd be great to have a system that works well in the summer, but if it fails in the winter, that's not really useful.
No.
So you've got to have a plan. These systems have to be designed to work well across all seasons.
Yep.
Winter and summer.
And then lastly, it's got to be economical.
It's got to be worth it. Yeah. And that's a function of design, maintenance, and the cost of electricity against the losses that those farms are seeing due to heat stress. And obviously that's going to vary with climate.
Well, I think you've summarized this episode nicely and have given everyone a recipe for going out and designing an effective ventilation system. And, I'm excited to hear how we can go out and assess the current systems to make sure that they are following this recipe.
That's the fun bit. We'll talk about how to assess these systems later.
Thanks for joining us.
Thanks.
The Dairyland Initiative is supported by industry leaders who are advancing cow comfort worldwide. We would like to say a special thank you to our premier sponsor, Saputo, who is providing the global community with high-quality dairy products made from high-quality milk from healthy and well-cared-for animals. We'd also like to say thank you to our other sponsors, SaveCows.com, Zinpro, GPS Dairy Consulting, 40 Barn, SureGain Trout Nutrition, Munters, J&D Manufacturing, VES Artex, Ventec, and Kestrel Instruments. Thanks for tuning in to the Dairyland Initiative podcast. Want more Dairyland Initiative? Be sure to subscribe to our podcast, follow us on our socials, and visit our website for all of the latest recommendations in dairy cattle housing and management. See you next time.